second and get to the note packet, page 5. So again, we have been learning up until now, we know how to look at an equation or a picture for that matter and find the vertical and horizontal asymptotes. We are still going to find vertical and horizontal asymptotes today, and we're going to use those two numbers, the vertical and the horizontal asymptote, to find the domain and range and end behavior. The good thing, there's good and bad news. The good news is the domain, range, and end behavior idea is exactly the same. The bad thing is it's a little bit different than last unit. Alrighty, but just a basic definition to refresh our memory on domain. The domain is all of the x values of a function. So remember, it's all of the x values. So all of the x values of a function. Let me move this over. All right, all of the x values. Again, the main idea is x values. I try to get this through to you guys. It's got to be the x values, okay? X values, and then so with the range, the domain, we just think of it as the leftmost point. What's going on the left side of the graph, comma, what's going on to the right side of the graph. Okay? And then the range, we know what the range is. The range is all of the y values of a function. So all of the y values. So range, when we use range, it's always going to be y values. So all of the y values. All of the y values of a function. And then for an example, it's how far down you go, comma, how far up you go. Remember, your range has to be, your domain and range need to be in the correct order. So your lowest number should go first and your highest number should go last. Alrighty, and then my favorite one, this one is my favorite because 9.9 out of 10 times all 20 of you get these questions right. End behavior. End behavior looks just a little bit different. So end behavior is still going to look like this part as x approaches positive infinity, f of x approaches blank. So that part's still the same. We'll talk about what's different in a second. And as x approaches negative infinity, f of x approaches blank. That blank is not straight. Again, whereas x approaches positive infinity, that's what's going on the right side of the graph. So what does the right end of my graph go to? And as x approaches negative infinity, what's going on with negative infinity? That's the left side of my graph. You guys are very, very, very good at end behavior. The only thing that's different right now, the only thing that's going to be different is before, don't write this down, just listen. Before, what used to go here was infinity or negative infinity. Not anymore. What goes here now, what goes in these two blanks now is going to be your y, it's going to be a y value. And it's going to be whatever number is your horizontal asymptote. And I'll show you why. I'll show you why that is when we get to an example. So make sure you write that down. So what's going to go in this blank, it's going to be the same number every time. So we no longer need to look at the leading coefficient, even, odd. That doesn't matter anymore. What goes in this blank is going to be the same number, and the number that it's going to be is the number that was my horizontal asymptote. And I'll show you why that is. It makes complete sense when we get to it in an example. Okay? And the whole rest of today is just examples. Questions so far? If you have questions, feel free to put them in the chat. Take about 10 more seconds to get this written down, and then we will jump into a few examples. Okay, so example 1 says identify the vertical asymptotes, the horizontal asymptotes, the domain, the range, and the end behavior. It looks like a lot of work. We have already not mastered the skill, but very much practiced the skill of looking at a graph and finding vertical and horizontal asymptotes. Once we find those, the domain, range, and end behavior come from those values. Alrighty, so I'm going to use this graph and find the vertical asymptotes. Now, vertical asymptotes are always in the form of x equals a number. X equals a number. If I'm telling you it's equal to x equals a number, you need to use an x value. An x value comes from the x-axis. This is the x-axis. So on your Target A homework, a lot of you were not using x values. This is an x value. And so to find a vertical asymptote, I look at where my graph gets vertically on each end. So this graph gets vertical over here. And this graph starts to go vertical over here. And so this gets vertical. This graph is a little weird because I give you the tick mark of 4, but this is 0. So I have a vertical asymptote. This graph is getting closer and closer and closer to this line right here. And that line happens at x equals 1. The x value, here's my x-axis. The x value that it happens at is right here, which is x equals 1. Okay, so I have a vertical asymptote at x equals 1. Okay. Alrighty. Then I have a horizontal asymptote. Horizontal asymptotes, again, I look at where my graph starts to get horizontal. And again, we struggle more with horizontal than we struggle with vertical. Horizontal asymptotes are in the form of y equals a number. Think about what that means. If you're telling me y equals, you need to use a number from the y-axis. This is a y-axis. You know that, but put those 2 and 2 together. The y-axis number, what you guys were trying to do on your Target A homework is you were like, well, Miss Bishop, this is going to -10 and this is going to +10. That makes no sense. And I was like, it's a y value. The y value from this y-axis that it reaches is 1, 2, 3. It's reaching 1, 2, 3. Whoops. It's going closer and closer to y equals 3, but never going to actually touch it. Because here's 4. This tick mark is 4, 1 below it is 3. So I have a horizontal asymptote at y equals 3. Any questions on why my horizontal and vertical asymptote are what they are? Alrighty, now let's use my domain and range. My domain, there's a couple different ways to think about my domain. My domain is no longer -infinity to +infinity. Why? Because I have asymptotes interrupting my graph. This is not one continuous graph. So my domain is all of my x values. And so I look at the ends of my graph. So all of my x values, remember domain is how far left and how far right my graph goes. So the left side of my graph is over here. Remember, this graph goes on forever. So this graph is going forever to the left. So this graph is going forever to the left. So my domain does include negative infinity, comma, right? And it goes from negative infinity, and I see how far left and how far right the graph goes. You have to do how far left and how far right this graph goes, and how far left and how far right this graph goes. So starting with the one on the left, this graph goes forever left to negative infinity, and the rightmost point it goes for x values, well, it doesn't cross this x value that's happening right here where I have my vertical asymptote. It doesn't cross an x value of 1. So my domain right now so far is negative infinity to 1. That should match, the number in your domain should match your vertical asymptote, always. Oopsies. Your domain should always match the number in your vertical asymptote. Why? There's a couple reasons to remember this. Domain is x values, so vertical asymptotes are also x values. So x equals 1, domain should also include that x value. It's how far left and how far right your graph goes. For these graphs, you should always have at least 2 domains. You're going to do the domain of each of these little graphs. So then I'm going to put my little union. Remember, when you have more than one interval, you're going to put a union there. I'm going to do the domain of this graph. The left side of this graph, x value wise, well, it doesn't, the leftmost point is also where my graph hits 1, x equals 1. And then the right side of this graph, seems to be going on forever for the x values to infinity. And you will start to notice patterns here. Alrighty. So my graph is not one continuous graph, which is why it's not negative infinity to positive infinity. It's not continuous because of my vertical asymptote at 1. And so it makes sense that I have an interruption at 1 in my domain. My domain is negative infinity to 1 in union with 1 to infinity, because this graph actually never happens at 1. Okay? Any questions there? I think you could already imagine what's going to happen with my range, but let's talk it through together. My range is a very, very, very similar process. My range is how far low and how far high my graph goes. I'm going to have always at least 2 ranges because I need to do the range of this graph and I need to do the range of this graph and put them together. The range that goes lower starts first though. So remember, your range always needs to go low to high. So I'm going to work with my left side of my graph first because my left side is the one that goes forever down. So this graph has a range of the lowest point in this graph. Remember, this graph goes forever, y value wise. This graph goes down forever. So this range goes from negative infinity. And the highest point that this green highlighted graph goes to on a y-axis, my y-axis, the highest point it goes to is going to be about here. And that's going to be where my horizontal asymptote happens. This graph does not go any higher. This graph highlighted in green does not go any higher than its horizontal asymptote, which happens at y equals 3. So the range happens from negative infinity to 3. And that should make sense because, again, my horizontal asymptote is a y value and my range is a y value. Okay? And then I need to do the range of my other graph. The lowest point of this graph over here, the lowest point is about here. And again, that happens at a y value of 3. And then this graph, the other end of this graph is going forever up, and forever up includes infinity. And again, that should make sense. You're going to start to see the pattern here. So the numbers from my vertical and horizontal asymptote are going to be the same numbers that I am going to use for my domain and range. It's just a matter of knowing which one goes with which. My vertical asymptote is going to go with my domain because they are all x values. Vertical asymptote is x value and so is domain. And my horizontal asymptote is going to go with my range because those are y values. And that should make complete sense based on the graph. My graph is interrupted at those points. Okay. One last thing we need to do is the end behavior. Alrighty. You already know what your end behavior is going to be based on what I told you, but end behavior is what are the ends of my graphs doing. So, end behavior as x approaches positive infinity, f of x approaches blank, and we'll fill in that blank in a second. And then as x approaches negative infinity, f of x approaches blank. So again, the notation is exactly the same. I already told you what number is going to go here when I defined what end behavior was, but let me tell you how to think of it. End behavior literally means what are the ends of your graphs doing? So remember, as x approaches positive infinity, that means what is the right end of your graph doing? The right end of my graph is not pointing up or down. The right end of this side of this graph is approaching not negative infinity or positive infinity, but what y value is it approaching? It's approaching the y value of 3, which is my horizontal asymptote. All right. What are the ends of your graphs doing? Same thing here. As x approaches negative infinity, that says what is the left side of your graph doing? Well, the left side of my graph is going to a y value of also 3. The left side of my graph is also approaching 3, which again, based on the definition, I told you what's going to go in that blank is your horizontal asymptote, which is what I have. So it looks like a lot of new things, but it's a lot of just using the same two numbers. Okay. What questions do you have? Alrighty, let's do it again. We're going to do a couple more examples so you feel the most prepared for your workday that you are having tomorrow. Alrighty, we've got this graph here. This graph here. I am going to just look at this graph. I've got good stuff happening here. I'm going to have a horizontal and a vertical asymptote. I have a vertical asymptote where my graph is going vertically. So if I extend this graph, remember these graphs go on forever. It's going vertical over here and over here. So my vertical asymptote, my graph is getting closest and closest to this point, but never crossing it. And that point that this line is happening, it happens at an x value. Your x values are over here, which you guys are very good at finding your vertical asymptotes. It happens at an x value of x equals -1. Looking at that graph, remember 0 is right here, so it's not 0 because this graph does cross 0, but this where this dashed line is happens at x equals -1. Remember, vertical asymptotes are in the form of x equals. Okay. Horizontal asymptotes are where my graph starts to go horizontally. It gets closest and closest to this number, but never actually crosses it. In the chat, where is my horizontal asymptote happening at? I already give you the line where it is, But in the chat, please, where does my horizontal asymptote happen at? What does it approach but not reach in the chat? Yes, it does reach 2. It approaches 2 but doesn't reach it. So y equals 2. Okay. Please do not forget the x equals and the y equals here. On your workday tomorrow, your question won't turn green if you forget the x equals and the y equals for your asymptotes. Whoops. Alrighty. Okay. One thing about this problem's a little different, and I want to show you why. This is the hardest type of problem we would do. This problem has a hole. We know what a hole is. We've talked about them before. This problem has a hole happen right here. There is a hole right there. It's kind of hard to see, but it is there. There is a hole in that graph, which literally means if I'm drawing this graph, I have to pick my pen up when I get there and continue. A hole is a discontinuity there. So that hole in my graph is discontinuous. This hole happens at about 5, 1. That hole happens at 5, 1. Over 5 and up 1, I have a hole. That's going to be an issue that we'll talk about. Okay, but until we get to that problem, let's keep going with our problem. But if you see, you always want to get in the habit now of looking at your graph and being like, do I have a hole? Alrighty, so now still, we'll worry about that hole when we get there. Let's do my domain. Well, first, I'm going to label this as a hole. My domain is how far left and how far right this graph goes. So you're going to find the leftmost point on this graph, which is over here. This graph goes forever to the left. So my domain is -infinity, comma. So just like before, just like last unit, the first number you're going to write is -infinity. So -infinity, comma, and it's going, I'm going to follow this. It's going to the right. But it can't go any more right than this point right here, which is going to be this horizontal asymptote is messing with it. So it can't go any more to the right than that point, which is going to be -1. So just like last time, my domain of my first graph is going to be -infinity, comma, -1. And again, that number should match my vertical asymptote. And then I'm going to go do the domain of my other graph. The domain of my other graph, how far left, the left side of this graph. Well, it can't go any more left, again, than my vertical asymptote. So union, remember when there's more than one, there's a union. -1, right? Those numbers are going to match. Those numbers will match. Listen here, though. Here's where it's a little bit different. There's a jump in my graph at this hole. So the x values are having a good time. This graph is going from the left to the right, but it gets to this hole and it's like, oh, I got to stop. It's literally like a hole in the road. So my graph goes from -1, the x values, to 5. And there's a jump in my graph. A hole is like a jump in your graph. So it stops at the x value. The x value of that point is 5. And then I'm going to pick my pencil up, jump over that hole, and then I'll be well on my way. So union 5 again, and then I'm well on my way forever to the right again towards infinity. Alrighty, just like increasing and decreasing, we're not having jumps though. We're not going to go from 5 to 6. There's a discontinuity at 5, but we're stopping at 5. We're stopping at 5.0, but we can put our pencil down at 5.01. So that there's a lot of numbers between 5 and 6, 5.01, 5.02, 5.0001. So we continue on. We don't skip over to 6. We do not necessarily skip 5. We do skip 5.00000, but we're going to do 5.00001. Alrighty, so all these numbers should match. The first number you write should be negative infinity. The last number you write should be positive infinity. And then we should have numbers that match still. Okay, if there was no hole, I would not have that middle interval, and I would just be from negative infinity to -1 and from -1 to infinity. But there is a hole. Alrighty, and it makes your range similar. It makes my range similar. So let's do it all over again with our range. So your range is how far low and how far high your graph goes. I hope you agree with me that these graphs will always go down to negative infinity. So the first number you should still always write for your range is negative infinity. If I'm starting my graph with negative infinity, then I'm doing the range of this side of my graph first then, because this side of the graph goes down to negative infinity. So if I'm starting my graph with negative infinity, I'm going to do the range of this graph. This graph happens at, so I'm going, the lowest point is from negative infinity, and then again, you can't ignore that hole. So at a y value of 1 in this hole has a y value of 1, there's a jump. So my range, how far low and how far high my graph goes, there's a jump at 1. So from negative infinity to 1, I jump. So for my range, in union with, and then I start again at 1 though. And then this graph, this side of this graph is trying to go as high as my horizontal asymptote will let me. My horizontal asymptote happens at 2. Okay. So I did the range of this side of my graph. I did do the range of this side. Now I need to do the range of this side of this graph. The range of that side, well, the lowest point of this side of the graph, the lowest point that it happens here is, again, my horizontal asymptote. My horizontal asymptote is 2 again. And that should make sense because I don't want any jumps. And then this end of this graph goes forever up. Forever up means infinity. So your range will still start with negative infinity and positive infinity, just like your domain will. But the numbers in the middle will depend on either your horizontal asymptote and your holes. Okay, any questions right now? Alrighty, and then end behavior, you already know what the end behavior is going to be without even looking at the graph. End behavior as x approaches positive infinity, f of x approaches blank, and as x approaches negative infinity, f of x approaches blank. Okay. The best advice I would give you is just to remember that what goes in the blank is always going to be your horizontal asymptotes. That would be the fastest way to do it. But for end behavior, if you want to think about it that way, is just what's going on in the right and left side of your graph. The right end of my graph is over here. It's approaching the y value of 2, which is my horizontal asymptote, and same with my left. These numbers will always be the same, and it will match your horizontal asymptote. Okay, questions? It's a lot of work. It's not necessarily hard math by any means. You're not calculating anything, but it's a lot for you to think about in this one picture. Okay. Alrighty, let's do one more example. Let's do another example on page 6. One last example on page 6. Page 6, I don't give you a graph. You don't need a graph. You know how to do all of this without a graph, okay? So you are going to have, you can find your vertical and horizontal asymptotes without a graph. You did that all day on Monday. Alrighty, so I'm going to start with horizontal asymptotes, and in order to do that, I'm going to look at the degree on the top and compare that to the degree on the bottom. In the chat, please, what is the degree on top? In the chat, please, what is the degree on top? Good, the degree on top is 1. The degree is the highest exponent. If there is no exponent there, it's 1. What is the degree on bottom going to be in the chat, please? One is again. So the degree on top, so the top equals the bottom. I'm not going to scroll back to the rules, but you know where to find your rules on page 3. If the top is equal to the bottom, then your horizontal asymptote is equal to the leading coefficient of the top number divided by the leading coefficient of the bottom. So y equals the leading coefficient on top, which is 2, divided by the leading coefficient on bottom, which is 1. The leading coefficients are the numbers in front. So I have a horizontal asymptote at y equals 2 divided by 1, which is 2. Okay, questions on that? We're good at that. Okay. Now for vertical asymptotes, I need to do my 3 steps. In the chat, please tell me yes or no. Is anything going to factor? Yes or no? The top or the bottom? Is anything going to factor? Don't think too hard about it. It's not a trick question. No, nothing's going to factor. So that means there's no holes. Life is good when there's no holes. So there's no holes. So to find my vertical asymptote, I just take what's left in the denominator and set it equal to 0. Subtract 4, subtract 4. I have a vertical asymptote at x equals -4. Okay. Maybe you're like, Miss Bishop, how are we going to do this without a graph still? Remember, your domain and range have everything to do with your vertical and your horizontal asymptote. If there's no holes, your domain and range are very simple. Alrighty. My domain, my graph still goes forever to the left, but it's going to be interrupted at an x value because my domain is x values. My domain is going to be interrupted by a certain x value. I wonder what only certain x value I know of without graphing that's important. My domain is going to be interrupted by an x value of -4 because that's my vertical asymptote. An asymptote is an interruption in your graph. So I know that my graph is going to go from -infinity to -4, stopping at -4, and then the other side of my graph is going to start at -4 and go on to positive infinity. Remember, when there's no holes, your domain and range are very simple and have everything to do with your vertical and horizontal asymptote. Now your range is very, very similar. Your range goes, your graph is going to go forever down, but it's going to be interrupted by a certain y value because ranges are y values. The y value that it's going to be interrupted by is your horizontal asymptote, which is 2. Your graph is going to stop at 2, and then your other graph is going to start at 2 and go on forever up to infinity. So remember, these numbers have everything to do with each other. Okay, and then my end behavior is going to be very quick. I know that my end behavior is always going to be equal to my horizontal asymptote. As x approaches infinity, f of x approaches blank, and as x approaches negative infinity, f of x approaches blank. What's going to go on my blank is my horizontal asymptote of 2. Alrighty. One thing you can do to check your work, or if you really don't like this problem, is you could have put it in a Desmos graph, which I can let you do, but you still need to show your work for these problems. You can put this in Desmos to check your work and see the graph, but you need to show your work. When I don't give you a graph, you need to check your work. So you could have gone to Desmos, which I did put the link in the chat before class. You could have put in 2x divided by parenthesis x plus 4, making it big. You could have seen this graph. And you could have seen it. You could have been like, I'm not quite sure where this asymptote is, but from